Hi, I'm going to talk a little bit about open source geospatial and map tools for mobile devices. So first I'm going to talk a little bit about weather apps and how they make use of these sorts of toolkits. Map display, of course, and my personal favorite, which is data visualization, which is kind of a catch-all term for anything not in the other two categories. So I make a toolkit, which I'll talk about shortly, called WhirlyGlobe-Maply. I'm a software engineer and an iOS and Android consultant. That is, I do mobile development for a living. I also do a lot of 3D development, so 3D interaction on tablets and mobile devices and things of that sort. And I'm also an open source contributor. I use a lot of open source toolkits, and I make my own as well, which I'll talk about now. So I make the WhirlyGlobe-Maply toolkit, and that is a high-performance geospatial display toolkit for iOS and Android. So it's used on iPhones and iPads and Android devices for maps, 3D globe displays, things of that sort. It has an Apache 2.0 license, so it's pretty free to use, and it's based on OpenGL ES 3.0, which basically means it's fast. It can often achieve 60 frames a second on mobile devices. It does a wide variety of different things, including displaying vectors, base maps, labels, shapes, and things of that nature. And as I mentioned, it's for iPad, iPhone, and Android. So a lot of different people use it. There are different categories of users. For example, there are civil aviation apps which use it. Those are apps for private pilots. There are also map display apps, things that display kind of a traditional 2D map, something you might expect to get from Google Maps or Apple Maps. There are geography apps, and those are apps for use with students that usually show the globe in 3D and allow for some interaction. And then lastly, there's data visualization, which again is kind of a catch-all term for anything not in the other categories. Let's take a look at a weather app. This one is called Dark Sky, and it's made by Forecast.io. And those guys make forecast stuff basically for the US and the UK. And this app is something that you might run on an iPhone or an iPad just to kind of see what the current weather is and whether or not it's going to rain anytime soon. So this is the globe itself is implemented in Whirly Globe, and they're using it with their own overlaid data. And as you can see, you can animate the weather, you can move around, see what the weather's like in your area, and so on. And this covers a number of complicated pieces of functionality. As you can imagine, there's a lot of imagery to download here to display in real time. There's a lot of paging going on as you move around. And they can also switch data sets. So for example, we could look at the temperature as well as the precipitation. And that'll take a second to load. So the temperature data set shows temperature over the last few days, and I'm not sure it's as useful as weather, but it certainly is pretty. Okay, back to the slides. So as I mentioned, there are a lot of interesting problems related to weather apps. One is the animation, of course. You need to be able to show the user how things change over time. That requires a lot of memory, and of course a weather app is tied to the current time, so you have to deal with regular updates. You can't just cache all the data and then show it. The data becomes invalidated fairly quickly. And the rendering itself can get fairly complex. There's lookups involved for this false color image, for example. So let's take a look at another category of apps, the map display app. Now, map display is something that's probably very familiar. A lot of us use maps on mobile devices, either Apple's Maps or Google's Maps or somebody else, and there's just a huge variety of somebody else's out there, some of which use this toolkit. So the technology can be offline versus online. That is a connected map app like Apple's Maps, for example, or an offline map like one you might get from a variety of vendors. And it's basically the purpose of a map is to show you where you are or where you are in relation to other things. So let's take a look at a quick example here of a map app, or I should say map data. So this example here is using OpenStreetMap data from Brazil, and it's what's known as a vector map. And vectors are much more flexible than images. Basically, there's two ways of doing modern maps. One is to have everything pre-rendered into image tiles, and the other is to have basically vectors for each tile and then process those as they come in. The second is what everyone has moved to. Both Google and Apple are using vector maps now, and the rest of the industry is kind of following that as well. And this example here is a vector map of Sao Paulo, Brazil. Now, one of the nice things about vector maps is that everything can be fairly smooth. Labels can interact with each other. Markers can stay consistent sizes, that sort of thing. All right, back to the slides again. Now, I mentioned it briefly, but OpenStreetMap is an online map. You can go to openstreetmap.org and just take a look at the map. But it's also free data, so it's a volunteer-run organization where people contribute data to the map itself, either by tracing it off of imagery or actually going out in a car or a bike and running a trail and collecting a GPS track and then contributing that back to the map. Now, for a lot of my users, it's a great source of data because, again, it's free, but it's also improving all the time. So for most areas, it's pretty good, and for some areas, it's really, really quite good. So the last area I'm going to show you is data visualization, and that's sort of a catch-all term for viewing data in 3D or 2D and interacting with it that doesn't fit into all the other categories. So the reason I like doing data visualization on these sorts of devices is that, first of all, they're very friendly. You can hand a tablet to somebody and they'll start interacting with it. Users can really interact directly with the data, feel like they're close to it. And it's the kind of thing, you can just hand off to somebody and they'll start playing with it. And the devices are surprisingly capable once you've gotten the hang of their capabilities. So let's take a look at a quick example here. Now, this is an app called WhirlyViz, which does a variety of data visualizations in itself. It's actually scripted so that you can provide a script to do your own functionality, and it will handle the rendering part. So this particular data visualization is of the San Francisco Bay Area bike share system. So there's San Francisco. And if we zoom in, we can see what's currently going on with the bike share system. So for example, over here at Townsend and 7th, we're just about out of bikes. And over here at the Caltrain station, you can see there's a fair number of bikes. So that's live data, but we can also delve into historical data. So let's look at the most popular trips, the 50 most popular trips. Now these are the 50 most popular trips over a period of several months. And we can kind of dive in deeper. So let's take a look at the regular users, the subscribers. These are people who pay a yearly fee. And we can see that that has a certain pattern to it. I happen to know that's the Caltrain station, so there's a lot of people coming from there. And if you look over here, Townsend and 7th is an area with a lot of office buildings. It's sort of a logical place for people to go. And if you look up and down this street, there's some hops up and down what's known as Market Street. So let's take a look at a different category of users. Let's try customers. And these are people who just walk up and pay for a single bike ride, for example. And if you know anything about San Francisco, this is all tourists. So this is the ferry building here. Oh, sorry, that's the Fisherman's Wharf there and the ferry building here, right there. And that's the most popular trip. And that basically means that tourists are largely using it to run up and down the Embarcadero, which is a big tourist area in San Francisco. So you can also look at other historical information. For example, where are stations most likely to empty out? That's sort of the same thing we've seen here before. The tourist stations, pretty likely to empty out. The commuter rail stations, pretty likely to empty out, and so on. And you can play with that by time of day or day of week and so forth. Let's head back to the slides one last time. Okay, so just to mention a little bit more about that app, it's called WhirlyViz, and it's for geospatial data display for iOS. So it's just iOS only at the moment. And it's based on that WhirlyGlobe-Maply toolkit I was talking about. So it'll do a globe or a flat map, and you can overlay your own data on top, something that you put in a remote database and you can make queries against. It's JavaScript based so that it can interface to all sorts of different data sources and display the results with native code, basically native mobile code to make it fast. Okay, so here's some information about this talk. This is from a larger talk, so the slides are slightly bigger, but hopefully more interesting. And there's links to WhirlyGlobe-Maply, which is the toolkit that I make, as well as some of the apps that I mentioned in this talk.